So last time we were in the middle of 3.1, we're just about done, where we're doing this rectangle problem. And we were trying to figure out the width of the sidewalk. Okay, we had a pool that was 30 by 50. It has a sidewalk around the pool, and the sidewalk has the same width all the way around. So we drew the rectangle to represent like the sidewalk, and this region in here, that's the sidewalk. And we figured out the only way that you could find the area of the sidewalk is if you took these two squares, two rectangles, and subtracted the areas. Right? If you took the area of the big red rectangle and you cut out the black rectangle in the middle, you'd be left with that border. And that border is the area of the sidewalk. So we started setting that equation up. This 600 came from the problem. They told us the area of the sidewalk was 600. The area of the pool, they didn't give it to us, but we can figure it out because they gave us the dimensions of the pool. It's 30 by 50. We multiplied 30 times 50 and got 1,500. And the only other shape we needed the area for was the red rectangle. So the red rectangle is 50 units long from there to there, but then it has the sidewalk on each end. And the sidewalk is X. So we added the sidewalk here to the sidewalk here and added it to the 50. And that's how we got 50 plus 2X. And for the width, well, the sidewalk is definitely 30 from there to there because it lines up with the pool. And then there's sidewalk on the top, sidewalk on the bottom, X, X, and 30. And that's how we got 2X plus 30. That's where we were. Okay, so now we need to, I'm going to copy that down. Actually, can I get blank? Yeah, I got blank space down here.
Would that be double, technically, both of those?
Nope, everything we have there is good.
Yeah, we have two sides to worry about.
But we're finding area, not perimeter.
Oh, okay.
Yeah. Okay, so what was that term I just mentioned for doing out two sets of parentheses when you have to multiply? Yep.
Foil.
Yep. So we're going to FOIL that out. What's 2x times 2x? That'd be 2x plus 2x would be 4x. You got to be careful with our exponent. 4x squared. Okay. 2x times 30 is how much? About Caleb? 2x times 30?
That would just be 60x.
60x. James, 2x times 50?
2x times 50 is 100x.
100x. Okay. And Brett, what about 50 times 30?
150. 1,500.
1,500. What's going to happen on the end there? Yeah, that always happens in this kind of problem. It's just the way if you have a rectangle within a rectangle and you're doing exactly what we're doing, these two numbers always cancel out. All right. So you're left with 600 equals 4x squared. How about Alejandro, 60x plus 100x?
160x.
160x. Yep. Now that's a quadratic equation because the highest exponent in it is a 2. Does anybody remember one way you can solve a quadratic equation? Yep.
Did you square root
You can complete the square. We're not going to do it that way, but you can complete the square. That's one way. Two others.
Oh wait, isn't the way to make one side like a perfect square, so you think the square root?
So yeah, we're not going to complete the square, but yep, you can do it that way. Does anybody remember another way besides that? To solve a quadratic? Factoring. So you can factor it. And there's one other way. Anybody remember a quadratic formula?
The name?
The name?
Yeah.
All right. Well, we're going to need the formula in a minute. But to solve with quadratic formula, you first have to get this equal to something. Not equal to 600. What are you supposed to get it equal to? Supposed to get it equal to 0. So how could we move that 600 over to the right side?
Subtract 600 from both sides.
Yep, subtract 600 from both sides. Now, this isn't technically part of using quadratic formula, but all these numbers are divisible by what?
4.
Yeah, so if you want to divide through by 4, you can make all the numbers a little smaller. It's just going to make it a little easier when we do the math. Okay, so I would divide everything by 4. And what's 160x divided by 4? Yeah, 40x. And how about Logan? 600 divided by 4 gives me
150.
Yep. Okay, so now we're ready to do quadratic formula. Give you a hint, it's got 3 letters in it. Does anyone remember? Starts out negative b. Does anybody remember part of it from there? So negative b plus or minus. Anybody remember what goes under the square root part? No? So b squared minus 4ac all over 2a. Does that look a little familiar? Maybe?
I learned this one time. At one point.
So,
Not right now.
looking at this equation, does anybody know what number a is?
4? No.
Isn't it
Well,
2x?
it's either going to be the number in front of x squared, the number in front of x, or the negative 150.
So 1.
It's 1. How about the b?
40.
That's the number in front of the x. And the c?
150. Negative.
Negative 150. Okay, we'll do more with quadratic formula. This is just kind of a little bit of a review to remember a little bit about it. Now we fill those numbers in and then see what we get. Keep in mind, we're solving for width. What kind of number does width have to be? Since it's a distance.
Positive.
It's got to be positive. So if there's an answer that gives us a negative, we can cross that one out. Because quadratic formula will always give you 2 answers. But we know the width of the sidewalk has to be 1 answer. All right, so negative b plus or minus the square root of b squared. 40 times 40 is 1600. 4 times 1 times c. We're going to divide that by 2a. What's 2 times a in this case? How about Kyle? 2 times a would be?
2 times a.
Yep. A is 1.
2.
2. Yep. All right, so we have negative 40 plus or minus, let's do 4 times 1 times negative 150. 4, well, times 1, that doesn't do anything. That's negative 600. So the minus is from the formula, and then we have another minus with our number. What happens when you subtract a negative number? Yep, it becomes positive. So I'm just going to kind of go like that. Okay. What's 1600 plus now, not minus, plus 600? 2,200, yep. Okay. So let's type that in, and that's our answer. Well, one's going to come out negative, one's going to come out positive. Let's do the plus first. Negative 40 plus the square root of 2,200 gives me 6.9. And then divide by 2. 3 point, if we're going to round that to 2 decimal places, what would that round to? Cassie?
3.45.
Yeah, 3.45 feet. Now, you don't have to worry about the negative 40 minus, because if you do negative 40 minus the square root of 2,200, what kind of number did we get? Negative. And if you divide that by 2, what kind of number will you still have? It's still negative. So negative number wouldn't make sense for the width in this problem. So that is the width of the side. Okay, that's a tough question. There's a lot going on there because you've got to set up a quadratic equation. If you don't remember 100%, that's okay. We're gonna talk more about quadratics as we go on. Okay. So, all right. So the last thing in 1.3 is how you graph what's called a piecewise function. And what a piecewise function is it's basically 2 graphs drawn on the screen at the same time. An example might be like, let's say I had ticket prices. And if you were under 6, there was a certain ticket price. If you're between 6 and 18, there's another price. And if you're over 18, there's a third price. So I might have 3 different formulas. The first formula I would apply to anybody who's under 6 years old. The second formula would apply to anyone that's between 6 and 18. And the third formula would apply to anybody over 18. So what I've done is I've broken my domain into 3 parts. Less than 6, between 6 and 18, more than 18. And I'm going to use a different formula to calculate your ticket price based on your age. You can break the domain into as many parts as you want. 2, 3, 4, 20. All right. A lot of times 2 is pretty common. But what I want to show you is how you type it in. So this is a formula that breaks the domain up into 2 parts. Essentially numbers smaller than 1 and bigger than 1. If you have a number that is smaller than 1, and you're asked to plug it in, you might say, well, wait, I've got 2 different formulas. Which one do I use? It tells you right here. So if I picked, let's say, the number 0, and I wanted you to plug it in and tell me the answer, would you plug 0 into the top formula or the bottom formula?
The top.
You plug it into the top because 0 is less than 1. What if I said 5? Top or bottom?
Because it's greater.
Yeah. So it's just a different formula depending on what you're plugging in. Are you plugging in something less than 1, or are you plugging in something 1 or higher? But no matter what number you tell me, it's going to go in one of those 2 formulas. It has to. Right, so let me show you how you type that in on a calculator. So to graph this on a calculator, the calculator can't do it perfect, but this what I'm about to show you is as good as we can do. So you press y equals, okay, in the upper left. If you have anything on your screen, you're going to clear that out. And now we're going to type in 3 minus x squared, but in parentheses, just like this. Now, if you type that in and you hit graph right now, it's just going to graph 3 minus x squared. But what I basically want it to do is stop right there. I don't want to see any of this. I only want to see the part from 1 down, because that's what the top is. It's just from 1 down.
Why? Why does it matter? Like just visually or what?
Because that's just what this says right here. That's the question.
Like why can't you just ignore it though?
Because what we're looking at is how do you graph this on the screen.
Okay.
So this is not that yet. So to graph that, next to it in parentheses, you're going to type in x is less than 1. Does anybody know where the less than sign is? You have to press a button to get to it. If you're not sure, I'll tell you what button. You wouldn't know by looking at it unless you used it. No, it's not under list. It's under test. Second, math. Math is the third button down on the left-hand side. If you press that, that's one way you can get to your inequality symbols. Second, math. And we want the less than symbol, and we want 1. Okay, let me hit graph now and watch what happens. It's going to start graphing it like it did before. But notice all of a sudden it just stopped. It didn't. Yeah, it just kind of did this flat line. I can't get rid of that. If I could, that would be perfect.
Yeah, so it's inputting I think it just x is 0 for every.
Yeah. But essentially, it should just look like this blue part right here and nothing else.
I'm not getting that on mine. Is this did I graph that correct?
You didn't put the condition in parentheses. So just make sure you put x is less than 1 in parentheses. And then you just do this for as many as you have. We only have 2. So now just do the last one. In parentheses. X, I don't know if I told you where the exponent button is. It's below clear. It's like below the arrows on the right-hand side. So x cubed. Once you type cubed, hit the right arrow because you're done typing in the exponent. Minus 4x. And then next to it, we want to put in that condition. How do I get to my inequality again?
Second.
Second?
Math.
Math. This time I want greater than or equal to, that's the 4th one down. Okay, so that is what you should have. Let me hit graph and show you what it looks like. I'll do zoom 6. Ignore the part that's kind of flatlined. That shouldn't be there, but I can't get rid of it.
What do you mean flat line?
The part that's like right on the axis, right there.
Red and blue.
I'll just trace over it so we don't even see it. That's exactly what the graph should look like. It's the blue graph up till the number 1, and then it's the red graph from 1 and up. So it's 2 different graphs on the screen at the same time. And that's called a piecewise function. All right. Any question on that?
Are we going to do more examples of this?
That's the only piecewise function I was going to do. That was it. And the last thing we're going to look at today is just reviewing y equals mx plus b, slope, stuff like that.
Piecewise,
This is called a piecewise function.
Do we have an example of that on the homework?
Yeah, I'll pick one question out for that.
Okay.
You pick one. All right, so let me, don't copy that down because that's not. All right, so you guys already did 3 through 19. You did up to there. 24. 45. Yeah, let's just do on page, so for this part of the homework, just page 30. Yeah, it's just the first part. 45 and 46. Okay, so page 30, 45, and 46. Those are both piecewise functions just to practice on the calculator. Just like I typed in right there.
And that's gonna be on homework?
Yep, that's what 45 and 46 is like the one I just did right there.
Okay.
I mean, it's a different picture, but it's the same steps. All right, so the last thing we're going to look at, I don't think there'll be anything new in this section, is a review of the equation of a line, okay, from Algebra 1. When you write the equation of a line, the format you usually use is called y equals mx plus b. Does anybody remember what the m stands for? Has to do with the steepness of the line. Yep, the slope. And does anybody remember what the b stands for?
Is the y-axis.
The y
Intercept, sorry.
intercept.
The y-axis axis.
Yep. So anything that you can write in the form y equals mx plus b is a line, and that means it's called a linear function. So anything in the form y equals mx plus b is called a linear function. Okay, so any questions on y equals mx plus b? We'll do some examples, but just what the m and the b are. So I want to talk a little bit more about the m part, which is the slope. Sometimes people remember the slope, there's two words. They both begin with an R. Does anybody remember the two words I'm thinking of? The blank over the blank? Yep.
Rise over run.
Rise over run. Yep. And if you don't remember how to calculate the rise or how to calculate the run, I put the formula up on the board. So slope is y2 minus y1 over x2 minus x1.
Could it be y1 over y2 or just?
Yeah, as long as you're consistent. I'll stick with that just so I don't confuse people, but just as long as you're consistent, yep. So you had 2, 3, and I don't know, somebody else pick a different coordinate.
1, 7.
1, 7? Okay. So if I wanted to find the slope that goes through those 2 points, what's y2?
7.
Sure, 7. What's y1?
3.
3. What's x2?
1. 2.
And x1? 2. 7 minus 3 gives me 4
Negative 1.
over negative 1. And what's 4 divided by negative 1?
Just negative 4. So that's the slope.
That would be the slope. If you drew a line through those 2 points on the paper, it would have a slope of negative 4, which means it slants which way as you go to the right? Negative would slant
Down left.
down to the right.
Down to the right.
Up and to the left is a positive slope. Down and to the right, or I'm sorry, yeah, up and to the right, positive. Down and to the right, negative. So it would look like this one. Might be a little steeper, but something like that. Now there's two special lines, horizontal and vertical. Does anybody remember the slope of a horizontal line?
It's just 0.
Yep, 0. How about the slope of vertical? This is a little different. It's not a number. Yeah?
That's the one with the 0 in the denominator.
That's the one where if you tried to calculate it, you would be dividing by 0, which you can't do. So what do we call that slope? Undefined. Yep. So those are two special cases of slope. Horizontal is 0. Vertical is undefined. So y equals mx plus b, that's the standard equation you can use when you're finding equation of a line. Horizontal and verticals, those are special cases. Horizontal and vertical lines are not y equals mx plus b. Horizontal lines are y equals a number. I'll show you on the calculator. So if I type in something like y equals 5, I'll get a horizontal line at 5. X equals is a vertical. I can't show you graphing a vertical because the calculator doesn't do that. So let's say you had the point 2, 3, right there. What would be the equation of the horizontal line that goes right through that point? Yep.
Y is 3.
Y equals 3. Yep. What would be the equation of the vertical line that goes through that point? X equals 3 would be over here. 1. X equals 2. Okay, so just what I'm trying to show you there is horizontal and vertical lines are a special case. That's it. Any question on that? Which one of these can you do on the calculator?
Horizontal,
Yeah.
but not vertical.
Yeah, you
because
can't.
it's allowed.
Yeah, you can't do vertical because it's always y equals. You can't change it to x equals. Is there anything else? Yep. Okay. So what I have on the board now is this 2x plus 3y equals 6. Is that y equals mx plus b? No.
But you could put it in that form.
Exactly. We can change it into that form. That's what I want to do. What would be your first step to get 3y by itself?
Yeah, you move divide 6 by 2x.
So this is a positive 2x. How would you get rid of positive 2x? A negative 2x.
Yep. Oh.
So subtract 2x on both sides. Minus 2x. And when you write that on this side, how would you write it? But have it be in that order.
At least you're pretty
Negative 2x plus 6.
Yeah, we want to put the negative 2x first and the plus 6 second. Okay, so y equals mx plus b. You got to get used to the x first. And then how would you get rid of this 3? Yeah, you divide because this is multiplication right here. 3 times y. So you divide by 3. And where would you divide by 3?
The side thing.
Yep. And when you do the side, you have to do it to both of them. So that's going And what are we left with for the slope?
Negative 2/3 x.
Negative 2/3 x. And what are you left with for a y-intercept if you simplify? 2. So now, having it in that form would make it easier to do what? A lot easier than when it was in this form.
Graphing.
Yeah, it's easier to graph because we know the slope and the y-intercept. Yep. That's the advantage to doing that. All right, so another format that we do use to write the equation of a line, it's not as common as slope-intercept, but it's called point slope. Does anyone remember seeing y minus y1 equals mx minus x1? No. Remember that? Okay, so this format is helpful when you do not know the y-intercept. They give you a point that's on your graph. So they give you an x and they give you a y. And they give you the slope. Okay, this is called point slope. If a problem says to write an equation of a line, you could choose whichever one you want. Point slope or y equals mx plus b. Let me show you how you use this one. So it says find the equation of a line where the slope is a half and the point that it goes through is negative 2, 3. So first, I just want to make sure we know what these numbers are. What letter represents the 1/2 in that formula?
M.
That's the M.
And then would you put negative 2
What's that one?
x1?
Yep.
And then
3.
y1 is 3.
Yep. So you always have to plug in for this one, and that one. Those are the 3 that you fill in. And that's it. So the answer is y minus, what's y1 in example 3? Yep. Equals,
1/2.
m is 1/2.
Parentheses x minus negative 2, or plus 2.
Yeah, it's going to be x minus 2. When you have minus a minus, that's going to turn into a plus.
That's just the answer.
And that's the answer, yep. You could put that in y equals mx plus b. What would you have to do with this 1/2 to do that?
You have to, whatever, you have to put in, so, what do you call that?
Begins with a d.
Yeah, distribute.
Distribute, yep. So if they said now take your equation and put it in y equals mx plus b, you would have to distribute the 1/2 out. Just like that. And what else
Combine like terms.
would you have to do to get that in y equals mx plus b?
You do minus 3 on both sides, or sorry, plus 3 on both sides.
You do a plus 3 on both sides. So that's exactly the same answer as up above. It's just arranged in a different way. Point slope, slope intercept. The directions in this problem did not say to do that. I'm just showing you how, if you ever have to rearrange it, you can. Any question on that? So another thing they mention here is parallel and perpendicular lines. Can somebody tell me, what does it mean if 2 lines are parallel? Yep.
Yeah,
They never touch. Yep. So what else would that mean would be the same
they
about
have the
them?
same slope.
Same slope, but different what? They have to have different intercepts. Well, what if they had same slope, same intercept? Why aren't they parallel?
Because they're just the same line.
Well, that's just the same line like this. That's not parallel. So parallel is same slope, different intercept. Now, what about perpendicular. This one's a little bit harder to remember. It's something with the slopes, and the slopes are blank, blank. 2 words.
They intersect at one point, but
Yeah.
isn't it a slope just like a T?
Well, that's kind of like the shape
Sorry,
they
the
would make.
perpendicular, I mean,
Yeah, so they cross at a 90-degree angle. But does anybody remember how the slope here compares to the slope here?
The opposite.
Special connection between them. Yep.
Opposite.
Opposite is part of it.
Opposite,
The
negative.
slopes are opposite and, so opposite would be negative, yeah. So one's positive, one's negative. They're opposite
Flip it.
and
Can't remember what it's called.
flipped. What do you call it when you flip something? Like when you flip a fraction. It's the,
Reciprocal?
yeah. Yep. So if you had a line with a slope of 2/3, what would be the opposite reciprocal of 2/3?
3/2.
That's the reciprocal,
Negative 3/2.
negative 3/2. So if you drew those 2 lines with those slopes, they would be perpendicular. So perpendicular, opposite reciprocals. Okay. So this is the kind of problem that you'll see. Write an equation of a line that's parallel to that and goes through that. Well, if you're going to be parallel to this, what's the first thing you have to know
The slope.
about that? Yeah, you got to find the slope of it. If you can't find the slope, then you're not going to be able to be parallel.
How do you find the slope of that?
So how do we find the slope of this? We did that earlier.
Oh yeah, y equals mx plus b.
Get it in y equals mx plus b. Bring the 3x to the other side. How do I get rid of that negative 2? Well, it's negative 2 times y, so what's the opposite of times?
Divide.
Divide. And what do we divide by?
2. Negative 2.
Negative 2. Yep, because we want to cancel the number and the negative. We don't need to finish the y-intercept. All I need to know is the slope, because I'm just trying to be parallel to that line.
3/-2.
Okay, so what's my slope?
3/-2. Negative. Oh wait, sorry.
3
Negative.
over 2.
3/2.
Well, look at the negative, so.
Negative divided by negative is a
Oh. Okay.
positive. Yep. Okay, so now we know the slope of this line is 3/2. I want to be parallel to that line. So what is the slope of a line that's parallel to 3/2?
3/2.
3/2. They're the same. If it said perpendicular, I'd be flipping that and making it the opposite now. But it didn't say perpendicular. It says parallel. So that's my slope. What's the point that my line has to go through?
Negative 2. 1.
1,
Negative 2.
negative 2. Now, it's just like the problem we did right here. They gave me a slope, they gave me a point, fill them in. There's your slope, there's your point. So it's y minus, what comes after the minus here? Negative 2. Y minus y1 equals, what comes right after the equal sign? M. And what comes after the x minus? X minus x1. Minus a minus is really just going to be a 1.
Whoa. I'm so confused. You lost me on that last writing that equation part.
So I took those 3 numbers
Yes.
and I filled them in those 3 spots. I filled in y1, m, and x1. M is 3/2. y1 is negative 2, and x1 is 1. And that's how you get your equation. So plug that in there, plug that in there, and plug that in right there. And that's what it turns into. Oh, I just didn't fill in the sorry.
Is that like the final answer?
Yep, that is the final answer. I didn't fill in that 3/2 right now. That's the last one. All right, the last thing. So when we talk about linear lines, we also usually talk about inequalities. People remember like shade above, shade below, solid line, dotted line, kind of stuff?
Yeah, some,
A little bit?
a little bit.
So when we're graphing an inequality, okay, here's an example of what one could look like. So a line, and then shade. That's an example of like what we're doing. That's like a final answer, what the picture looks like. So there's 2 steps when you're graphing an inequality. The first step is graph the line. Start by graphing your line. So I'll just make one up and do it as we go. Let's say y is less than 2x plus 3. Okay, pretend like it's y equals 2x plus 3. That's how you graph it. What's my y-intercept here? Yeah, positive 3. How do you get to positive 3 when you want to graph your y-intercept?
You go up 3 on the y-axis.
Yep.
Why was positive 3 the
Y is what?
so why was positive 3 the y intercept?
Because there's a positive 3 right here.
Okay, well, like why wouldn't it be like 2? I mean, I guess you can't graph 2x, so.
Yeah, your y-intercept is always the b.
Yeah.
Yep. So the first thing is, it says start by graphing the line. If your problem has an equal to under the inequality, less than or equal to, greater than or equal to, you need to make your line solid. If it doesn't have the equal to, we make the line dotted. So what's this one going to be? Solid or dotted?
Dotted.
Yep, it's going to be dotted. And to get one more point on my line, I need to use my slope. What number could you put in the bottom even though it's not there? Yeah, we could make it 1. What does it mean when the rise is 2 and the run is 1? Which way do you go? Yep.
That means you go up 2 on the y-axis, over 1 the x-axis.
Over which way?
To the right.
To the right. Yep. Up 2, right 1. Now, once you get 2 dots, that's enough to make your line. Did we say solid or dotted?
Dotted.
Dotted. Now, the last thing, it's written a little small, but it's right above. It says shade below or shade above. Less than symbols, you shade below. Greater than symbols, you shade above. So, which one is this? Shade below or above?
Shade below.
Yeah, shade below. So it would look kind of like this. It doesn't have to be perfect, just kind of like that. And that's how you graph an inequality. Okay, so 1.4, I hope maybe that point slope you don't remember, but I'm hoping like y equals mx plus b, that kind of stuff. Hopefully it kind of jogs your memory a little bit. All right, so homework, let me adjust that.
You said page 30, 45, and 46.
Yeah, it might actually be page 31, because those are later problems. It's probably 31. So it's just going to be page 31, 45, 46. So 2 questions there, and then 10 questions on that one. So it's 12, I think it's 12 questions altogether. All right. So that's 1.4, and we're going to push one of the sections we were going to do to next academic week. So tomorrow we'll do 1.5, and then Friday will be 1.6. There's no test this Friday. Okay. Well, I mean, you have the option. You could do a test.
No, it's okay. I'm good. We're okay. I'm all set.
Extra credit.
Well, if you do the test, then there's no homework. If we don't have a test, there is.
I'm down. I'm down
I'll
for
do
this.
the homework.
I'll do the test.
It sounds like more people want to do the homework, so we'll have our first test then after shop.